Hello, in this lecture we will find out the diameter of the semicircle. In the drawing we have a semicircle. We know that AB is the diameter of this semicircle. We also know that chord AD equals to 7 units in its size, chord DC equals to 15 units, and chord CB equals to also to 15 units, and we want to find out the size of the diameter that is AB. Okay, we know that the diameter of this semicircle is AB, but we don't know the size of AB, and we want to find out the size of AB or the value of AB. So first of all, we'll make a construction. We will join together points D and B by a straight line. Actually, the peripheral angle ADB, this angle is a right angle equals to 90 degrees. According to rule number 1, rule 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees in its size. So I'll read rule number 1 again. Rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees in its size. So actually we have here a peripheral angle ADB that rests on AB, called AB, that is the diameter of the semicircle. It is given us at AB in the question that AB is the diameter of the semicircle. Therefore, according to rule number 1, peripheral angle that rests on the diameter of the circle or the semicircle is equal to 90 degrees. Therefore, the peripheral angle ADB equals to 90 degrees in its size. So the peripheral angle ADB equals to 90 degrees according to rule number 1. Okay, according to rule number 1, the peripheral angle ADB equals to 90 degrees in its size. Okay. So in the next step We will define the center of this semicircle as point O. This point, the center of this semicircle, is defined as O. And then we will join together points O and C by a straight line. And we will also join together points O and D by a straight line. In the next step, we will focus on two triangles. On triangle OCD, the green triangle, and we will also focus on triangle OCB, the orange triangle, so we will focus on triangle ODC, that is the green triangle, and triangle OCD, that is the orange triangle. Okay, so in those two triangles, we know that side DC of the green triangle equals to side CB of the orange triangle. Both of those two sides are equal to 15 units in their sizes. So side DC of the green triangle equals to side CB of the orange triangle. Both those two sides are equal to 15 units. Okay, side DC equals to side CB equals to 15 units. And actually OC is the radius of this semicircle, because of the fact that it starts from point O, that is the center of the semicircle, and ends at point C, and ends at point C, that is a point of the semicircle, itself. And also we know that OD is the radius of this semicircle for the same reason, because it starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point of the semicircle itself. Therefore, OD is the radius of this semicircle. We will define the radius of the semicircle as R, so OD equals to R. OC also equals to R. And OB is also the radius of this semicircle for the same reason, because it starts from the center of the semicircle and ends at point B that is a point on the semicircle itself. Therefore, it is the radius of this semicircle. So actually OD equals to OB. Both of those two line segments are the radiuses of the semicircle, therefore they are equal to each other. So OD, the side of the green triangle, is equal to OB, that is the side of the orange triangle. Both those two sides are equal to R. Okay, OD equals to OB equals to R. And OC is a common side because it belongs both to the green triangle, and side OC also belongs to the orange triangle, triangle OCB. Therefore, we can write down that OC equals to OC. It is a common side. It belongs to both triangles. Okay, so we actually proved that all the sides of the green triangle, all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we actually proved that the green triangle is congruent to the orange triangle according to side rule. Okay, so triangle, the green triangle, triangle OCD is congruent to the orange triangle, triangle OCB, according to side rule. So I will read again the things that I want. Triangle OCD, the green triangle, is congruent to triangle OCB, the orange triangle, according to side rule. Side rule states that if you have a triangle that all of its sides are equal to another triangle, then those two triangles congruent to each other according to side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce that this angle OCD, is equal to this angle OCB. Again, angle OCD is equal to angle OCB. Again, angle OCD is equal to angle OCB, according to the rule that states that corresponding angles in congruent triangles are equal to each other. The green triangle is congruent to the orange triangle, therefore the corresponding angles that are angle OCD and angle OCB are also equal to each other. Okay, so if we define angle OCB as alpha, then angle OCD will be also equal to alpha because those two angles are equal to each other. So angle OCD is equal to angle OCB. Both those two angles are equal to alpha. Okay. In the next step, we will focus on triangle A, BCD. This triangle BCD. In triangle BCD, we know that side CD of this triangle is equal to side CB. Both those two sides are equal to 15 units because it is given us in the question. So side DC of triangle DCB or BCD is equal to side CD equals to side CB. Both of those two sides are equal to 15 units. And we also know that those two angles are equal between them. They are equal to alpha. So angle OCD in the green triangle is equal to angle OCB in the orange triangle. Both those two angles are equal to alpha. Okay, again, side OCB is equal to side OCB is equal to side OCB is equal to side OCD. Again, side OCB is equal to side OCD. Both those two angles are equal to alpha in their sizes, and they are equal to each other. And OC is a common side. It belongs both to the green triangle, and OC also belongs to the orange triangle. So OC equals to OC. OC equals to OC. It's a common side. It belongs to both triangles. Okay, OC equals to OC. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we actually proved that triangle here actually we must define this angle, this side, this point as point E. And here we focused on triangle BCD. So we know that side DC is equal to side CB, and we have rule number 2 that states that in front of equal sides there are equal angles. So I write down rule number 2. Again, we focus on triangle BCD. in triangle BCD, we know the side DC of triangle BCD is equal to side CB of triangle BCD. Both of those two sides are equal to 15 units in their sizes. Okay, side in triangle BCD, side DC is equal to side BC. Both those two sides are equal to 15 units in their sizes. And here we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So I write down rule number 2. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually, if you focus on triangle BCD, in triangle BCD we have two equal sides. Those two sides are equal to each other. Both of those two sides are equal to 15 units. So according to rule number 2, in front of equal sides in the triangle there are equal angles. So in front of these sides in triangle DBC we have this angle, and in front of this side in triangle DCB, in front of this side we have this angle. So those two sides in triangle DCB are located in front of equal sides. Therefore, according to rule number 2, they are also equal to each other. So actually, according to rule number 2, angle EDC this angle is equal to angle EBC, this angle. Again, according to rule number 2, in front of equal sides there are equal angles. Therefore, angle EDC is equal to angle EBC. And if we define angle EDC as theta, then angle EBC will be also equal to theta. So if we define angle EDC as theta, then angle EBC will be also equal to theta because of the fact that those two angles are equal to each other. Okay? So in the next step, we will focus on triangle DEC, triangles DEC, and triangle CEB. Actually, on the green triangle and the orange triangle. Okay, so in those two triangles, we know that side DC of the green triangle is equal to side CB of the orange triangle. Both those two sides are equal to 15 units. Okay, so side DC of the green triangle is equal to side CB on the orange triangle. Both those two sides are equal to 15 units. Okay, so side DC in the green triangle is equal to side CB on the orange triangle. Both those two sides are equal to 15 units. And also those two angles are equal to each other, so angle DEC in the green, angle DCE in the green triangle, angle DCE in the green triangle, this angle is equal to angle ECB in the orange triangle. Both those two angles are equal to alpha in their sizes. Okay, those two angles are equal to each other, so side DCE is equal to side ECB. Both those two angles are equal to alpha in their sizes. And actually side EC is a common side. It belongs both to the green triangle, triangle ECD, and it belongs also to the orange triangle, triangle ECB. So EC equals to EC. It is a common side. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we actually proved that the green triangle is congruent to the orange triangle according to side angle side rule. So I write down the things that I said. Actually, triangle DEC, the green triangle, is congruent to triangle ECB, the orange triangle, according to side angle side rule. So I read again the things that I want. The green triangle, triangle DEC, is congruent to the orange triangle, triangle ECB, according to side angle side rule. So side angle side rule states that if you have two triangles, if one triangle is equal to other triangle in two sides and the angle included, then those two triangles are congruent to each other according to side angle side rule. Okay, here actually we proved that those two sides and the angle included in the green triangle are equal to those two sides and the angle included in the orange triangle. Therefore, we proved that those two triangles congruent to each other. Okay? So, from the fact that those two triangles congruent to each other, we can deduce that angle DEC, this angle in the green triangle, angle DEC in the green triangle is equal to angle CEB in the orange triangle. Again, angle DEC in the green triangle is equal to angle CEB in the orange triangle according to the rule that corresponding angles in congruent triangles are equal to each other. Therefore, we know that the green triangle is congruent to the orange triangle. Therefore, those corresponding angles are also equal to each other. And if we define angle DEC as x, that is to say angle DEC equals to x, then because of the fact that those two angles are equal to each other, then angle CED will be also equal to x. Okay? So here we can write down that angle DEC equals to angle CEB equals to x. Both those two angles are equal to x. And we actually contracted the chord DB. We connected points D and B by a straight line, therefore DB chord DB, this chord is a straight line. DB is a straight line. And okay, DB chord DB is a straight line, and we have a rule about straight lines that states that the sum of the angles along a straight line at a certain point and at one side is equal to 180 degrees. So if we focus on point E and on the upper side of the straight line DB, then according to the rule that I mentioned, the sum of those two angles must be equal to 180 degrees. Okay, the sum of those two angles along the straight line DB must be equal to 180 degrees. So, but this angle is actually angle DEB. So actually, angle DEB must be equal to 180 degrees from one side according to the rule that I mentioned. Okay, the size of angle DEB is 180 degrees from one side, that is from one side, but from the other side, what is the size of angle DEB? Angle DEB equals to x plus x. So angle DEB, according to our definition, equals to 2x. So we actually have this equality, and from this equality we can deduce that 2x equals to 180 degrees. 2x equals to 180 degrees. So if we divide this equality by 2, we will get that x equals to 90 degrees in its size. X equals to 90 degrees. So we can substitute those two angles that are equal to x by 90 degrees, because x equals to 90 degrees. So here instead of angle x, I will draw a right angle. This is a right angle, and also this angle x also equals to 90 degrees. So I will draw a right angle. This angle also equals to 90 degrees. So here we have two angles that are equal to 90 degrees in their sizes. In the next step, we will focus on chord OC. Actually, from the beginning, we connected points O and C together by a straight line, but also we know that OC is the radius of the circle, of the semicircle. Yes, OC is the radius of the semicircle because it starts from point O and ends at point C. It starts from point O, that is the center of the semicircle, and ends at point C, that is a point on the semicircle itself. Therefore, OC is the radius of the semicircle. OC is the radius of the semicircle. Therefore, it must be a straight line, but as I've already mentioned from the beginning, in the beginning of the lecture, we connected points O and C by a straight line. So OC is a straight line. And it is also a straight line because it is the radius of this semicircle. So OC is a straight line. Okay, chord OC is a straight line because we built it as a straight line, and also because it is the radius of this semicircle. So again we have the rule of straight lines. If we focus on the left side of the straight line OC and at point E, then we can say that the sum of the angles at the left side at point E must be equal to 180 degrees. So this angle with the arrow, this angle must be equal to 180 degrees. But what this angle that I drew by the arrow consists? What it consists? It consists angle CEB that is 90 degrees, and it also consists angle OEB that we don't know the size of angle OEB, but we know that in total the size of this angle is 180 degrees. So we got the equality that states that the sum of those two angles is, one is right angle and the other one is angle OEC. In total the sum of those two angles is equals to 180 degrees. So from this equality we can subtract 90 degrees, and we will get the value of angle OEC. Angle OEC will be equal to 180 degrees minus 90 degrees. It will be equal to 90 degrees. Okay, so angle OEC is a right angle. So this angle OEC is a right angle, so this angle equals to 90 degrees. Okay, so we have around point E three angles that are right angles, and we will define the fourth angle. We will define this angle as angle Y, and we know that the sum of those two right angles is equals to 90 degrees times 3 is 270 degrees. The sum of those two three angles is equal to 270 degrees. Okay, and we have a rule number 3. Rule number 3 states that the sum of the angles around the point, is equal to 360 degrees. Is equal to 360 degrees. So I will read rule number 3 again. Rule number 3 states that the sum of the angles around the point is equal to 360 degrees. Okay, so, and especially the sum of the angles around point E must be equal to 360 degrees according to rule number 3. But what is the sum of the angles around point E? The sum of the angles around point E is the sum of the 3 right angles that are equal to 90 degrees times 7 is 270 degrees plus the size of the fourth angle, that is y. So according to rule number 3, we can write down the following equality that states that the sum of the angles around point E is equal to 360 degrees, and the sum of the angles around point E is actually equals to 270 degrees plus the size of the fourth angle, that is y. In total, the sum of the angles around point E must be equal to 360 degrees according to rule number 3. So here we got the equality that states that the sum of the angle around point E is equal to 360 degrees according to rule number 3, and from this equality we can subtract 270 degrees and we will get the value of y. Y will be equal, angle y will be equal to 360 degrees minus 270 degrees is actually equals to 90 degrees. So angle y is equal to 90 degrees in its size. So angle y is actually a right angle. So we can substitute angle y by a right angle. So we found out that all the angles around point E are right angles, they are equal to 90 degrees. So in the next step, we will focus on the right triangle, triangle ADB, and the small right triangle, triangle OEB. I will draw them again. So I draw again triangles, the big triangle, triangle ADB, and the small triangle, triangle OEB. Note that around point E all the angles are right angles, so this angle is also a right angle. As you can see from the drawing, this angle is a right angle. So I'll copy it here. It is a right angle. So on those two triangles, we have two right angles. So the angle ADB in the big triangle ADB is equal to angle OEB in the small triangle, triangle OEB, because both angles are right angles, therefore they are equal to each other. So we can say that angle ADB in the big triangle, triangle ADB is equal to angle OEB in the small triangle. Both those two angles are equal to 90 degrees in their sizes. Okay, we have first two angles that are equal to each other, they are equal to each other in both triangles. And we have also angle B, that is a common angle because it belongs to the small triangle, triangle OEB, and also angle B belongs to the big triangle, triangle ADB. So we can write down that angle B equals to angle B. It is actually a common angle. It belongs to both triangles, the big triangle and the small triangle, common angle. So the third pair of angles, angle DAB in the big triangle, is also equals to angle EOB in the small triangle. So those two angles are also equal to each other, so I write it down. Angle DAB in the big triangle is equal to angle EOB in the small triangle. And that is according to they are equal to each other according to third angle theorem. According to third angle theorem. Actually, third angle theorem states that if you have two triangles that has two equal angles, two angles in the first triangle are equal to two angles of the second triangle, then the third pair of angles in those two triangles must also be equal in both triangles according to third angle theorem, because the third angle actually completes the sum of the angles in the triangles to 180 degrees. Okay, therefore the third pair of angles must be also equal in both triangles. Okay, so we actually proved that all the angles in the big triangle, triangle ADB, are equal to all the angles in the small triangle, triangle OEB. Therefore, we actually proved that those two triangles, the big triangle, triangle ADB, and the small triangle OEB, are similar to each other according to angle similarity. Okay, so triangle ADB, the big triangle, is similar to the small triangle, triangle EOB, according to angle similarity. Okay, those two triangles are similar to each other according to angle similarity. Angle similarity according to according to angle similarity rule. Angle similarity rule states that if you prove that two triangles has three equal angles, that all the angles in one triangle are equal to all the angles of another triangle, then those two triangles are similar to each other. So we proved that those two triangles, the big triangle ADB and the small triangle OEB, are similar to each other. Therefore, because of this similarity between those triangles, the following relationship exists between the sides of those two triangles. The relationship between the sides of those two triangles, of those two similar triangles, is OB over AB. OB, that is the side of the small triangle, over AB, the side of the big triangle, equals to OE over AD. OE is the side of the small triangle, over AD is the side of the big triangle. Okay? Actually, in any similar triangles, this relationship exists between the sides of the similar triangles. Okay, OB over AB equals to OE over AD. So, what is the value of OB? OB equals to R. Also, OA is also equals to R because it starts from the center of the circle, of the semicircle, and OA, line segment OA, ends at point A, that is a point on the semicircle itself. Therefore, OA is defined as the radius of this semicircle. So, what is the value of AB? AB equals to R plus R, that is 2R, and we also know that AB is the diameter of the semicircle, so the diameter of any circle or semicircle is always twice the size of the radius. So AB as the diameter of the semicircle equals to 2 times the radius of the semicircle. Okay, it equals to OE over AD. What is the value of AD? AD equals to 7 units. So in total, we got this equality that R over 2R equals to OE over 7. So here R over R is 1. So we got that 1 over 2 equals to OE over 7. Here we can multiply this equality by 7 and we will get that OE equals to 7 over 2 units. OE equals to 7 over 2 units. OE equals to 7 over 2 units. I will write it here. OE equals to 7 over 2 units. And what is the size of CE? CE equals to OC minus OE. Again, CE equals to CO minus EO. Okay, CE equals to CO minus EO. So CE equals to CO. CO is the radius of this semicircle, so it equals to R. And what is the value of EO? EO equals to 7 over 2 units. So actually the value of CE is R minus 7 over 2 units. So we can write here that CE equals to R minus 7 over 2 units. Okay, CE equals to R minus over 7 over 2 units. So in the next step we will focus on two right triangles. Here we have triangle CEB in the orange color. Angle CEB of triangle CEB equals to 90 degrees. Therefore, triangle CEB is a right triangle. And also, we have triangle OEB. Angle OEB in triangle OEB equals 90 degrees. Therefore, triangle OEB is also a right triangle. So we can implement the Pythagorean theorem on those two right triangles by the statement that EB square equals to EB square. EB square equals to EB square. As you can see from the drawing, the side EB belongs to both triangles. It belongs to triangle, the right triangle, triangle CEB, and it also belongs to triangle OEB, so it is a common side that belongs to both triangles. So the statement EB square equals to EB square will relate to those two triangles. Here EB square will relate to this triangle, triangle EOB. EB square in triangle EOB, this triangle will be equal to OB square minus OE square. OB square minus OE square. That is the third EB squares. Again, EB square relates to this triangle. EB square in this right triangle equals to OB square minus OE square. We have the second EB square in this quality, and the second EB square will relate to this triangle, to this right triangle. Here EB square will be equal to CB square minus EC square. Okay, here EB square will be equal to CB square minus EC square. Okay, CB square minus EC square. Okay, so we got this equality, but what is the value of OB? OB equals to R, so OB squared is R squared. What is the value of OE? OE equals to 7 over 2 units, so OE squared will be equal to 7 over 2 squared. 7 over 2 squared is 49 over 4. And what is the value of CB? CB equals to 15 units, so CB squared is 15 squared. 15 squared is 225. Minus EC squared. What is the value of EC? EC equals to R minus 7 over 2 units, so EC squared will be equal to R minus 7 over 2 squared. Okay, so in total we got that R squared minus 49 over 4 equals to 225 minus R minus 7 over 2 squared. So R squared minus 49 over 4 equals to 225. Here I will open the brackets. R minus 7 over 2 square equals to R square plus 7 over 2 square, that is 49 over 4, minus 2 times R times 7 over 2. So in total, we got this equality. R square minus 49 over 4 equals to 225 minus R square 14 plus 49 over 4 minus 2R times 7 over 2. Here 2 over 2 is 1, so 2 is cancelled. So here I will open the brackets and we will get that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4. Here we have 7 minus 7R, so it is plus 7R. Okay, so here we have minus 49 over 4 in this side of the equality, and we have minus 49 over 4 in the other side of the equality, so we can cancel minus 49 over 4. Here we will add R squared to this equality, and we will get that 2R squared equals to 225 plus 7R. So here we'll subtract 225 and also 7R from this equality, and we'll get a quadratic equation that 2R squared minus 7R minus 225 equals to 0. So in this quadratic equation, the coefficients of this quadratic equation is a equals to 2, b equals to minus 7, and c equals to minus 225. C equals to minus 225. Actually, the variable of this quadratic equation is also x equals to r, because the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So that is the general formula for a quadratic equation. Ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. And we'll find out the value of x according to a special formula for x that states that x equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay, so that is the solution for the quadratic equation, the formula for the solution for the quadratic equation. In this way we will find out the roots of this quadratic equation. So we have already found out that the variable in our quadratic equation is r. A equals to 2, b equals to 7, and c equals to minus 225. So we can substitute x by r, because the variable in our quadratic equation is r, equals to minus b. B equals to minus 7, so minus b will be equal to minus 7, that is plus 7, plus minus root of b squared. B is minus 7, so b squared is 49. Minus 4 times a is 2, so 4 times a is minus 8, times c is minus 225 over 2a. A equals to 2, so 2 times 2 is 4. So in total we got that r equals to 7 plus minus root of 49 times minus 8 times minus 225. Minus 8 times minus 225 is 1800, so I write it down. We'll get that r equals to 7 plus minus root of 49 plus 1800 over 4. So r equals to 7 plus minus 49 plus 1300 is actually root of 1849 over 2, here I made a mistake, it is over 4. Okay, it is over 4. So here we found out that r equals to 7 plus minus root of 1849 over 4. The root of 1849 is 43, so I will write it down. We got that r equals to 7 plus minus root of 1849 is 43 over 4. So we have here two solutions to this quadratic equation. The first solution is r equals to 7 plus 43 over 4. 7 plus 43 is 50, and 50 over 4 is 12.5. R, the radius of the semicircle, equals to 12.5 units according to this solution, but we have also the other solution that R equals to 7 minus 43 over 4. 7 minus 43 is minus 36. Minus 36 over 4 is minus 9. So we got that R equals to minus 9. But because of the fact that R is the radius of the semicircle, it must be a positive number, so it is impossible that R equals to a negative number. So this solution is cancelled, it is not true, and we left only with the solution that R equals to 12.5 units. So the radius of the semicircle is 12.5 units. So and the diameter, that is twice the radius, d, the diameter, that equals to AB. It is twice the radius, so it is 2 times 12.5. That is actually 25. So the diameter of the semicircle is 25 units. Again, I found out that the diameter of this semicircle equals to 25 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle. We know that AD equals to 7 units, DC equals to 15 units, and CB equals to 15 units also. And we want to find out the size of AB. That is, AB is the diameter of this semicircle. And in the first step, we made a construction. We joined points B and D by a straight line. And in this way we created angle ADB, the peripheral angle ADB. Actually, the peripheral angle ADB is equal to 90 degrees in its size. It equals to 90 degrees in its size according to rule number 1, that states that peripheral angle resting on the diameter of the circle equals to 90 degrees. Actually, the peripheral angle ADB, this angle, rests on the diameter AB of the semicircle. Therefore, according to rule number 1, angle ADB equals to 90 degrees. Angle ADB equals to 90 degrees according to rule number 1. And then we defined the center of this semicircle as point O, and then we connected together points O and C by a straight line, and we will also connect together points O and D by a straight line. And actually side DO, side OB and OA are all the radiuses of this semicircle, because of the fact that they exit from the center of the semicircle, that is to say from point O, and ends at the point on the circle, whether it be point D, point C, or point A. All the points are points on the circle itself, on the semicircle itself. Therefore, they are the radiuses of this semicircle. I defined the radiuses R, so they are all equal to R. Then we focused on the green triangle and the orange triangle. We know that DC equals to CB equals to 15 units. It is given us in the question. And also we know that OD equals to OB equals to R. Both those two sides are the radiuses of this semicircle, therefore they are equal to each other. And OC is a common side, and because it belongs to the orange triangle, and also OC, side OC belongs to the green triangle. So OC equals to OC, it is a common side. It's a common side, so we actually proved that all the sides of the orange triangle are equal to all the sides of the green triangle. Therefore, the orange triangle is congruent to the green triangle according to side rule. Okay? From the fact that those two triangles can go into each other, we can deduce that those two angles are also equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. So those two angles are equal to each other. Okay, angle OCD equals to angle OCB. Then we defined one angle as alpha, so the other angle must be also equal to alpha, because those two angles are equal to each other. So angle OCD equals to angle OCB, both those two angles are equal to alpha. Then we focused on triangle BCD, this triangle. On triangle BC, side BC equals to side DC. Both those two sides equal to 15 units. It is given us in the question. And we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. Okay, so we have in triangle BCD two sides that are equal to each other. CB equals to CD. So according to rule number 2, in front of this side we have angle theta, and in front of this side DC we have angle theta. We have this angle. In front of this side angle CB we have this angle, and then in front of this side DC we have this angle. So according to rule number 2, the angles that are located in front of equal sides are also equal to each other. So those two angles are equal to each other. Okay, so actually angle DCE is equal to angle ECB according to rule number 2. according to rule number 2, angle EDC equals to angle EBC. Those two angles are equal to each other because in front of equal sides there are equal angles. Okay? And if we define one angle as theta, then the other angle will be also equal to theta. So we define this angle as theta, so the other angle must be also equal to theta. Okay? Then we focused on two triangles, on triangle EDC and on triangle ECB. On those two triangles we have side DC of the green triangle is equal to side CB of the orange triangle, because it is given us in the question both those two sides are equal to 15 units. Okay, DC equals to CB equals to 15 units, and also angle DCE equals to angle ECB equals to alpha. Those two angles are also equal to each other. And we have side EC, that is, side EC is a common side of those two triangles. It belongs to both those two triangles, so EC equals to EC is a common side. So we actually proved that two sides and the included angle in the orange triangle are equal to two sides and the included angle in the green triangle. Therefore, we actually proved that those two triangles can congruent to each other according to side angle side rule. Okay, so from the fact that those two triangles can congruent to each other, we can deduce that those two angles are also equal to each other according to corresponding angles in congruent triangles are equal to each other. Okay, and if we define one angle as x, then the other angle will be also equal to x. Okay? And then we know that DB is a straight line because we constructed DB, we connected points D and B by a straight line, so the DB is a straight line. And we know that along a straight line, if we focus at a certain point, that is to say point E, and the upper side of that straight line DB, the sum of the angles will be equal to 180 degrees. So actually, angle DB equals to 180 degrees from one side. Angle DEB, according to the rule that I mentioned, equals to 180 degrees from one side. But from the other side, we defined those two angles that are equal to each other as x. So they actually equal to x plus x. It equals to the angle DB, so equals to 2x from the other side. From one side, angle DB equals to 180 degrees according to the rule that I mentioned, and from the other side it equals to 2x. So from this equality we can deduce that 2x equals to 180 degrees, and if we divide this equality by 2, we will get that x equals to 90 degrees. So we can substitute angle x by 90 degrees, and we substitute this angle x by a right angle. Then OC is a straight line because we connected together points O and C by a straight line. And we also know that OC is the radius of the semicircle, therefore it must be a straight line. So OC is a straight line, and then we have again the rule of the straight line. If we focus on the left side of the straight line OC and at point E, the sum of the angles must be equal to 180 degrees. Okay? That is to say, this angle that is a right angle plus angle OEB must be equal to 180 degrees. Again, the right angle that is 90 degrees plus the size of angle OEC must be equal to 180 degrees, because we have a rule that states that along a straight line, if we focus on at only one side of that straight line, in our example we focus only on the left side of the straight line OC, and at point E the sum of the angles must be equal to 180 degrees. So this angle is 90 degrees and this angle is angle OEC. So the sum of the angles, that is the right angle plus the size of angle OEC, must be equal to 180 degrees. Then we subtracted 90 degrees from this equality and we got that angle OEC equals to 90 degrees. So the third angle also equals to 90 degrees. This angle is the right angle. So around point E, we have three right angles. The sum of three right angles is 90 degrees times 3 is 270 degrees. So we have around point E, the sum of three angles that is 270 degrees, plus we define the fourth angle as Y, and we have rule number 3 that states that the sum of the angles around a point is equal to 360 degrees. Okay? We implemented this rule number 3, at point E. According to rule number 3, the sum of the angles around point E must be equal to 360 degrees, and we have already found out that the sum of the angles, the sum of the three angles around point E is 270 degrees. So 270 degrees plus the size of the fourth angle must be equal to 360 degrees, according to rule number 3 that states that the sum of the angles around a point must be equal to 360 degrees, and especially at point E, the sum of the angles must be equal to 360 degrees. The sum of the four angles that we have three angles that the sum of them is 270 degrees, plus the size of the fourth angle must be equal in total to 360 degrees. So we subtracted to 270 degrees from this equality and we got that Y equals to 90 degrees. So the fourth angle also is a right angle. So all the angles around point E are right angles. Then we focus on triangle ADB, the right triangle, triangle ADB, and the right triangle, the right small triangle, triangle OEB. This angle is the right angle, it equals to 90 degrees, therefore triangle OEB is the right triangle. So we focus on those, I draw again those two right triangles. So those two angles are equal to each other, both of those two angles are equal to 90 degrees in their sizes. Therefore they are equal to each other, so angle ADB in the big triangle equals to angle OEB in the small triangle. And we also have a common angle. Angle B belongs to the small triangle, triangle OEB, and angle B also belongs to the big triangle, triangle ADB. Therefore, it is a common angle. We can say that angle B equals to angle B. And the third pair of angles, angle DAB in the big triangle must be equal to angle EOB in the small triangle, according to third angle theorem that states that if you have two triangles that has two equal angles, or if two angles in one triangle are equal to two angles of another triangle, then the third pair of angles must be also equal between those two triangles according to third angle theorem. So the third angle, this angle DAB in the big triangle, must be equal to angle EOB in the small triangle. Okay, so we actually proved that all the angles in the big triangle, triangle ADB, are equal to all the angles in the small triangle, triangle EOB. Therefore, we actually proved that those two triangles are similar to each other according to angle similarity. And from this similarity, okay, according to angle similarity, the big triangle, triangle ADB, is similar to the small triangle, triangle EOB. So from this similarity, the following relationship exists between the sides of those two similar triangles. The relationship is OB over AB equals to OE over AD. Again, OB over AB equals to OE over AD. Okay, so, but what is the value of OB? OB equals to R, is the radius of the semicircle. What is the value of AB? AB is the diameter of the semicircle, therefore it equals to 2 times the radius of the semicircle, so it equals to 2R. So OB equals to R and AB equals to 2R. And what is the value of AD? AD equals to 7 units. Okay, so AD equals to 7 units. So we found from this equality that OE equals to 7 over 2 units. OE, this line segment, equals to 7 over 2 units. And what is the size of EC? EC equals to OC minus OE. Okay, or CE equals to CO minus EO. We know that CO is the radius of the semicircle, so it equals to R, and OE, we already found out that OE equals to 7 over 2. So CE equals to CO, that is R, and OE, that is 7 over 2. CE equals to R minus 7 over 2. So CE equals to R, CE here equals to R minus 7 over 2 units. Okay, so then we focused on two right triangles. Triangle OEB is a right triangle because angle OEB is a right angle, and triangle CEB is a right triangle because angle CEB is a right angle. So we have here two right triangles, and we also know that side EB is a common side. It belongs to both triangles. It belongs to the right triangle, triangle CEB, and the side EB belongs also to the right triangle, triangle OEB. So we created this statement that states that EB square equals to EB square. And the first EB square is related to this triangle, this right triangle. Here EB square equals to OB square minus OE square. EB square equals to OB square minus OE square. And the second EB square in this equality relates to this right triangle. Here EB square equals to CB square minus EC square. Okay, EB square equals to CB square minus EC square. But we know that OB equals to R. OB equals to R. And OE equals to 7 over 2 units. Okay? So OE square will be equal to 49 over 4. CB equals to 15 units. So CB square will be equal to 15 squared, that is 225. And CE, we found out that C equals to R minus 7 over 2 units, so CB square equals to R minus 7 over 2 square. So after we solve this simple equality, if we arrive to a quadratic equation that 2R square minus 7R minus 225 equals to 0. Here the coefficients of this quadratic equation. Here is A equals to 2, B equals to minus 7, and C equals to minus 225, and the variable of this quadratic equation x is R. Okay, and we have general formula for a quadratic equation: ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. And we will find out the value of x according to a special formula, this special formula that states that x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. And we have already found all the values of the a, b, and c, and x equals to r. So we put the data inside this equality, and we found out that two roots for r, two possible solutions for the variable of our quadratic equation, that is r. The first solution is that r equals to 12.5 units, and the second solution is that r equals to minus 9, but r is the radius of the semicircle, and it's impossible that it will be a negative number, so this answer that r equals to minus, this solution that r equals to minus 9 is not correct. We cancel this answer, and we left only with the possibility that r equals to 12.5 units. And if the radius is 12.5 units, then the diameter is twice the radius, so it will be equal to 2 times 12.5 units, that is 25 units. So the final answer to the question is that the diameter of this semicircle, that is also AB, and it is 2 times the radius of this semicircle, is equal to 25 units. Again, the diameter of this semicircle equals to 25 units. Okay, thank you very much.